अच्छा जी, बिस्मिल्लाहिर्रहमानिर्रहीम। Numerical number 8. A 4-meter long uniform ladder with weight of 120 newtons leans against a wall, making 70 degree above. Assuming that the wall is frictionless, but the floor is not, determine the forces exerted on the ladder by the floor and wall. This is a challenging numerical and a very important numerical. First, we first draw a free body diagram. Free body diagram. A free body diagram is the diagram of the body on which all the forces are acting, taking the body in isolation. For example, the against the wall, and is the wall is applying a reaction force Fw on the ladder. Similarly, it rests against a cemented floor, and as shown in the figure, Fg is the reaction of ground on the ladder, and W is the weight of the ladder, which is given. So length of the ladder is 400 meters. Sorry, length is 4 meters. The weight of the ladder is 120 newtons. And since the center of gravity of a ladder is at the center, so the center of gravity is located at 2 meter from either end, and the weight is acting vertically downwards. Now there is a reaction force of the wall on ladder, which is Fw. This ladder leans against the wall and rests on the floor with an angle of 70 degrees as given in the numerical. And there is another force, which is the force reaction force of ground Fg, which is acting on the same ladder. Now he says that assuming that the wall is frictionless, but the floor is not. So if we assume that there is friction, there is a force of friction on the floor, then the force of friction will be acting in this direction. And the force of friction is normally denoted by small f. So if there was no force of friction on the ground, the ladder would have slipped in the opposite direction. So there is friction on right, acting on right side, which is preventing the ladder from slipping on the left side. Now this is the free body diagram. We have drawn the ladder in isolation. Since the ladder is in equilibrium, so we can apply all the conditions of equilibrium on this ladder. We can say that sum of all the forces in x direction are 0, and sum of all the forces in y direction are 0. Now there are All the forces are either in x and y direction except one force, which is Fg. Fg is slanted at an angle of 70 degrees. So we first have to resolve Fg into vertical and horizontal components. So we say that the x component or the horizontal component of Fg is Fg cos of 70, and the vertical component of Fg is Fg sine of 70. So now sum of all components, sum of all forces in x direction is 0. Taking all the rightward forces as going into positive x direction and all the leftward forces as going into negative x direction. So taking small f, which is friction, as positive, then taking Fg cos of 70 as positive, and taking Fw as negative because it is in negative x direction. Now similarly, sum of all forces in y direction is 0. Fg sine 70 is in positive y direction. Fg sine 70, and 120 Newton is in negative y direction. So minus 120 equals 0. Now he has asked us in this numerical to find the reaction forces Fg and Fw. From this equation that I've written in orange, Fg will be 120 over sine of 70. So if I do it with calculator, sine of 70 is 0.939, and if I divide 120 by it, this will be 127.7. So Fg will be 127.7 Newton. So we can now at least put this Fg in this equation, and now there will be two unknowns. Originally in this equation there are three unknowns: small f, Fg, and Fw. Now we have found Fg. Fw is still unknown, so we can use the other condition for equilibrium, which is sum of all the torques is equal to 0. And as we studied in the chapter, it is very convenient to take torque at a point where maximum of unknown forces are passing. So if we label this figure as this point, we label this point as A, this point as O, and this point as B. There are maximum unknown forces at point A, because Fg was initially it was unknown, small f is unknown. So it is convenient to take torque of all the forces at A. So we say that sum of all the torques is 0 at point A, because we know that point forces have zero turning effect at the specific point. Now you have studied during the chapter that moment arm is the perpendicular distance. Moment arm is perpendicular distance from point of rotation to line of action of force. So if we have a spanner, and this is the point of rotation, and the force is acting in this direction at angle theta. So what will be the moment arm? Moment arm will be the perpendicular distance from line of action to of force to the point of rotation. So if this is the force, we'll have to find the vertical component F sine theta. We'll have to find the vertical component F sine theta to find the perpendicular distance. Similarly, in this figure, there are two forces that are applying torque at point A. One is 120 Newton and the other is Fw. We have to find the vertical components of both the forces. If we consider this as point A, this is point O, they are making a right angled triangle with this with 70° at A, 90° at the other end. And since their sum of all the angles in a triangle are 180 degrees, so this angle O will be 20 degrees. This means that the force 120 Newton is making an angle of 20° with the ladder. So its vertical component will be 120 sine of 20. 120 cos of 20 will be in the direction of the ladder. This will be 120 cos of 20, which is not useful for us. The effective and useful component is 120 sine of 20. Similarly, for Fw, Fw is in this direction and it will have to make an angle of 70° with the ladder. The angle beneath is 70 degrees and this angle is also 70 degrees. And you have studied a theorem in class 10 that when a transverse line cuts the two parallel lines, there is a pair of alternate angles which is equal. So if the angle beneath is 70 degrees, the angle drawn in gray is also 70 degrees. So if this is 70 degrees, then the effective component, that is the vertical component of Fw, will be Fw sine of 70. Fw cos of 70 will be in the direction of the ladder, which is not required. The vertical component is required. So 120 sine of 20, which is this force, and Fw sine of 70, which is this force, are responsible for producing torque at point A. Now 120 sine of 20 is producing a clockwise torque at A, and Fw sine of 20 is producing a counterclockwise torque. So normally we take counterclockwise torque as positive and clockwise torque as negative. So sum of all the torques at point A is 0. So continuing from here, force into moment arm. Force is Fw sine of 70. Fw sine of 70. And the moment arm is 4 meter because it is at a distance of 4 meter from A. So into 4. And since it is counterclockwise, I'm taking it as positive. Then there's force of 120 sine of 20, 120 sine of 20, and its torque will be 120 sine of 20 into 2 because it is at a distance of with perpendicular distance of 2 from A. So multiplied by 2. And since it is producing a clockwise torque, it will be negative. And sum of both will be equal to 0. So if I want to find Fw from this equation, Fw will be 240 sine of 20 divided by 4 sine of 70. So if I do it using the calculator, sine of 20 divided by sine of 70 and multiplied by 240 by 4 will be 60. That's 60. 60 multiplied by divided by sine of 70. So it will be FW will be 21.84 newtons. So we have found both the reaction forces. If he is not asked to find us the friction, but if he asks us to find the force of friction, then this will be equation 1 and we'll put both the values in equation